Hi, Box Modders. Mike here. I thought I was ready to make this video before, and I fucking wasn't. So, this is my second try, after fucking around with this thing some more. What we have is, well, in the group, I'll put it this way, in the group we've had a few people ask, why not use an ESC, an electronic speed controller from an RC car, or RC vehicle of any kind, as a fucking mod regulator. Well, good question. And I'm going to tell you why you may not want to and why you may want to. So what I did is I picked up a brushed ESC. This is a 20 amp. I got a 30 amp over here. I got a fucking 40, 45 amp in the other room I'm going to fuck with later. These things are pretty cheap. This was like $5-7. This was a couple bucks more. The other one was a couple bucks more than that. This is a servo tester, which is necessary to make this thing work right. This servo tester was like $4, I think. I got another one over here that actually kind of sucks, even though it looks cooler because it has a display that doesn't fucking show you anything useful. Anyway, and I got a lot of beer, which is good. What am I drinking today? New Belgium Triple. Not bad. Let me get a little focus here. What do we got? Where is it? They're 7.8%. Not bad. I love Belgian style ales, doubles and triples. Make me happy, and they make me feel a lot better when I'm modding. So yeah. So I've been messing around with this thing. And how it works is, first off, the reason I used a brushed ESC is brushless ESCs, and I am speaking from not a position of a lot of experience with these. I'm speaking from a guy who read Wikipedia pages and forums and shit. So if you RC guys want to correct me, do so. Tell me in the comments if I'm fucked up. I don't know everything, despite what people like to say about me. And anyway, brushless ESCs have create a three-phase output, or at least an AC output. From everything I've read, it said they're generally three-phase, and that's mainly why you can't use it with an atomizer. You don't have now. If you could have a 510 connection with enough connections to make to power three coils and have a proper three-phase output, that'd be badass. Until then, this guy is going to be a little different. This puts out a pulse width modulation signal, PWM, haha. And you know how fond I am of PWM. Once I found that out, I was like, holy shit! You know, there's a good chance of applying this to a mod application. Not only is there a good chance of applying this, but this is all like pre-packaged, put together stuff. This is this servo tester. All you do is plug. This plug is attached to the ESC. You plug this into the servo tester, and you adjust the output just like that. And it goes from zero throttle to 100% throttle is how they name it. And the way I have it set up right now is the only thing you have to do to modify this setup to make it work with as a mod would generally work. So what this thing does, it puts out the PWM signal. It goes from 0% duty cycle. Actually, it goes from about 10% as its lowest active duty cycle. And I'm going to see if I can even demonstrate that. It's a little bit lower. There, that's about as low as it goes, and that's fine. By the way, this thing is good for 2S or 3S LiPo. Its operating voltage range is 6 to 12 volts, 6 to 12.6 volts, which is the bottom end of 2S and the top end of 3S. So that's how that comes out. I got my beater minkies in there. This is my little breadboard. They live in the little breadboard holder. I was at 8.1 volts when I started playing with this. That's how long I've been fucking around with this thing this afternoon. And anyway, so you can turn it down, all the way down, or you can turn it up, straight voltage. There you go. Lots of heat. And you can back it off just a little bit and get, keep backing it off until I get, see, just itty bitty bitty pulse there. Just itty bitty pulse. And you can go like the middle. You see all I'm doing is turning this thing. Just turning it wherever I want it. And then hitting the fire button. Now, a modification that I was going to tell you about that I fucking haven't yet. We have this MOSFET. This happens to be an IRLB 3813. That's all I have on hand. That's really all I buy. I like them a little better than 3034s. They have a little better switching numbers. On and off time is a little quicker, and they are cheaper than the 3034s. So there you go. There's no reason you can't use a 3034 for this. This is just my personal preference, and don't take that as anything important because I don't really make a lot of MOSFET mods. That's not really my thing. I'm a regulated guy through and through. So this is just one guy talking as far as that goes. Why is the MOSFET there, and what does it do? Well, I'm going to take it out first off, and this is going to be real fucking fun to get back in, holding the camera. I'm going to take it out, and I'm going to reconnect my ESC to my atomizer, and you see it's just going to fire. I'm going to turn it all the way down. So I turn it all the way down, and we got nothing. So I start turning it up, and yeah, that's the minimum, and we turn it up until the maximum. Crackling, crackling. And then we turn it down. Okay, so why not just put a switch on here? Well, the problem is this guy looks for a signal from this guy. What you see right here is zero output, and that's fine. If I had the ability, this thing only has one working channel, by the way. The other channel's fucked up, and that's why I really can't do this. But if I had a stand for my phone, but too fucking lazy to get one. If I could read you the output on here, you would see that this is a pulse. This is actually a PWM box itself, but it's a different kind. It has a 1 millisecond pulse. So right now it's putting 1 millisecond pulses into this guy. This guy says, hey, 1 millisecond pulse, that means zero throttle. Zero throttle. Then, turn it up halfway, it's about a 1.5 millisecond pulse. This guy says half throttle, and that's what we see right about there. That's about halfway. We'll call it halfway. You're going to turn it all the way up, 2 millisecond pulse. That's full throttle. We're going to turn it all the way down, 1 millisecond pulse. So that is a reference point for this guy. So that's why you cannot just use a pot. You can't just hook a pot into this thing. Oh, it's got 3 wires, you can hook a pot into it. Don't fucking do it. That's not how these things work. This servo tester has a standard output of 1 millisecond to 2 milliseconds, and that is translated by a servo controller or by an ESC to say, this is how fast I should go. This is what my output should be. And that's a standard, and you see a lot of industry standards like that. In measurement and instruments. I'm an instrument technician by trade, so that's kind of near and dear to my heart if I had one. Like 4 to 20 milliamps is a standard that if you had an instrument that measured 100%, it would measure 100% at 20 milliamps. If it measured and then at 0%, it would measure at 4 milliamps. 3 to 15 psi. There's plenty of others out there. So this is a standard. 1 millisecond to 2 milliseconds is a standard. Okay, so that's all fine and good. So why, Mike? Why can't I just plug this in, and just fucking go? Well, we need to switch it somehow. And we can't, emphasize, we can't switch it at the battery. So I'm going to turn this bitch up about halfway, and I'm going to pull the batteries. Get this out of the way. Pull the batteries. Batteries pulled. Okay, batteries going back in. It was at halfway. What's going on? Let's see. What does the scope say? This is why a scope is vital when dealing with PWM any kind of way. It's freaking out. This is some kind of panic mode that it goes into. It's because when you turn this ESC on, when you power it up and it sees the throttle is not at 0, it freaks out. So I have to turn the throttle back to 0. I do that, it goes back to normal. Then I can turn it back up. Crackly, vapey goodness. Okay. How's my juice level doing in there? Let's see. No, I'm good. I'm pretty good. Anyway, so that's the issue. You can't switch it from here. You can't switch it from here because it needs to see that signal. And I can't show you this, but if you pop this thing out and put it back in, like simulating switching it, it'll do the same thing. It'll freak out. You can't switch the tester input. In an RC car, by the way, this would be hooked up. This would be hooked up. This would be a receiver, wireless receiver. Then you have your little wireless controller in your hand, and you make the car go vroom. Yeah. So anyway, what is the solution? The solution is a MOSFET. Yay! We always use MOSFETs. That's always the solution, right? Okay. Now here's the deal. This is switched on the negative. And why is that familiar to you? Because what else do we switch on the negative? We switch, we use in-channel MOSFETs to switch on the negative. So this thing is probably driving an in-channel MOSFET. What does that mean to you? That means, notice here, I have this positive output wire connected to the positive of my atomizer. Now I'm going to put it right here. Get in there. Get in the hole. And it's not connected to anything. I'm going to take this jumper and I'm going to put it in the positive spot. And this jumper goes... Where does it go? I'm going to pull my batteries out because I'm going to end up fucking something up here doing this on camera. This jumper is going to go to... Nope. Told you. Positive. So we're jumping this positive and this positive. And these, I measured this with an ohm meter, there is continuity straight through from this positive to this positive. So these positives are not isolated. What does that remind you of? A MOSFET box. These negatives are isolated from each other. So when I plug this back in, we have life. My positive output is not connected, yet we have life. We have crackling. Proof right there. So anyway, what does that mean for how we can switch this thing? Well, what we have to do, batteries off. When you change something on a breadboard or anything, pull the batteries. Just don't risk any kind of fucking shenanigans, guys. It ain't worth it. So you can plug this back in or you can leave it out. I'm going to plug it in because this jumper is fucking chintzy as hell. And I'd rather just do it that way. What we're going to do is we're going to add a MOSFET. But we're not going to add a MOSFET the way that we normally would in a MOSFET box. We're going to run this, and I'll make, don't worry guys, I'll make a fucking diagram for you so you'll fucking not freak out on me. First thing we're going to do, we're going to plug the MOSFET in. How do we have the MOSFET plugged in? Well, let's see. Red is gate, because we're looking behind it, so we have gate, drain, source, right to left. We have red, we have gray there in the middle, that's our drain, and we have black, that's our source. And we have our source that we're going to plug into the negative output of this guy. We have our gate, which is already connected to a switch, which is going to connect to positive, just like we always do in an in-channel MOSFET. It turns on with positive. We have a resistor right here. This resistor doesn't mean anything. All it does is provide me a lead to clip my fucking ground clip to. This resistor goes from our negative to our positive. It goes from source to gate, just like it always does. You can also take this and just put it from ground to gate, which is way over there, which is why I didn't do it. This will work just fine. So when we fire it, this is going to go through the MOSFET. So this is not switching the MOSFET on and off. All it does is all this does is break the circuit. It opens up the circuit, then when we fire it, it puts the circuit back on. So let's power it up. Let's turn it up. Remember, and that's the thing, no matter what, this thing has to be turned back down. And that is probably the biggest disadvantage to this setup, is you have to turn this guy back down to 0, then turn it up where you want it, then fire it. And notice, boom, just like before. Just like that. Want to turn it up, we can turn it up and do that. Now, so if you guys want a master switch or a battery cutoff or anything like that, understand every time you disconnect the batteries, you're going to have to turn this bitch back down and then turn it back to where it was. Then you can fire it. And notice, let me get in real close so you can hear it. Can you hear the buzzing? Can you hear the humming? Yeah, it's because it's PWM. The whine, the characteristic whine of PWM, is not unique to the 555 design that I posted in the group. It's any PWM setup that's within audible range is going to whine. So stop your whining, because this thing will do it for you. Okay, so let's see. So I disconnect an ESC. I'm in the middle of it. I disconnect the ESC. I'm going to plug another one in. Let me plug this bitch in. Let's see. I'm going to do this without fucking killing anything. And, okay. So I got this bitch plugged in. And I turn it up like halfway. Like I said, this doesn't fucking mean anything. And it probably does, but I don't know what it means. Here we go. So you turn it all the way down, and this one, when you turn it all the way down, and this is a problem, is it goes into a panic mode. This is past the 0 point, so you got to turn it up. I've noticed you got to turn it up to about 80 something, maybe 90, and there it goes. Now it recognizes it. Now it's at 0, and that's why this guy is kind of problematic. So we turn it up a little bit. We're good. We turn it up a little more. This is all the way. 230 is all the way. There you go. Flat. This could probably be like degrees. Like, this is a servo tester, so obviously a servo is going to move in degrees. I don't know. You fucking RC guys tell me what it means if you're so fucking smart. And this one also has a lot of like everything from 170 up to 230 is max, or give or take, and then down to like past 90 is fucking nothing. So I'm gonna turn it up. This is like at 94, whatever, and still nothing. Turn it up 98, still nothing. 107. There you go. So, and that also depends on where it is when you plug it in too. So this one, not crazy about it. It's got a display, which is, yeah, that's great. The fucking display doesn't help you. So not crazy about that one. It costs more than the other one. They're both equally chintzy too. This is like, someone on a forum described this plastic as like, if they made a plastic version of cardboard, this is what it would be. And yeah, pretty fucking valid description, I would say. Not crazy about this. But the nice thing is that gives you less stuff you have to remove if you want to stick this in a mod. So that's good. Same thing here. This is heat shrinked. I may actually take this heat shrink off and see what's inside of it, and that'll be another video. So when you're hooking this thing up, S plus minus, your signal wire is white, your plus is red, and your black is, or your negative is black. So you want to hook that up just like that, and turn it up to like whatever, halfway, and no, there you go. That wasn't happy. Let's see where I'm at. Okay, now we're all the way down, halfway. There we go. There we go. Okay, so you can kind of hot swap these a little bit. You have to take a little bit of care when doing that. Otherwise, guys, if you want to make a PWM mod and you want to spend like, I don't know, 10 bucks or so, shipping from Hobby King sucks. It's like minimum $6. You're paying like full priority shipping price, like you're buying it from someone's house, which yeah, whatever. You think they'd get there? Maybe it is someone's house. Who fucking knows? So you're in like 16-20 bucks, but you only have to know how to make a MOSFET mod for the most part to make this work. So give it some thought, and you know, there's DIY ways to make this, there's DIY ways to make this, but that's not really the purpose of this, and I want to make that clear. This is not how to make from scratch, from discrete components and ICs, a PWM. This is for you guys who are not having a good time with it and want to make something else. So limitation, 20 amp, pulse 30 amp, I think. I don't have the little piece of paper that it came with that said all that. This guy is 30 amp, pulse 40 amp, I think, maybe. I don't know. And I got another one that's like 45 amp, pulse even more. So these are limitations. You have to keep that in mind. This is not like the PWM where the limitation is in the MOSFET. This MOSFET is not your weak point. You have to abide by the limitations of this, and the MOSFET doesn't change that in this case. So keep that in mind. But for, you know, 20 bucks in, and you don't really have to do a lot of work to get this bitch running, not a bad deal, really. As always, questions, comments, concerns, down below. If you're in the fucking Facebook group, pen post up above, fucking read it, and good job.